G'day, legends. Have you ever wondered how all the beautiful critters out there in the big wide world handle the weather? Think about it. One day it's hotter than a shearer's armpit, and the next it's so cold you could freeze the tail off a kangaroo. We humans just throw on a jacket or jump in the pool, easy as pie. But what about our animal mates? They can't just pop down to the shops for a jumper, can they? They've got their own brilliant built-in tricks for staying just the right temperature. It's a massive part of their everyday life, a real battle for survival every single day. Every animal on this planet has a perfect temperature, a sweet spot where their body works best. It's like their engine's ideal running condition. If they get too hot, things start to go haywire. If they get too cold, they can slow right down to a stop. So nature came up with two ripper ways of dealing with this. Some animals are like their own personal power stations, creating heat from the inside out. Others are more like solar panels, soaking up all the warmth they can get from the world around them. It's a fundamental split that decides everything about how they live, where they live, and what they do all day. This whole temperature game is what scientists call thermoregulation. That's a big fancy word, I know, but all it means is keeping your body at the right heat. It's a full-time job for every single creature, from the tiniest little gecko to the biggest blue whale. You see, the temperature of an animal affects its speed, its ability to hunt for a bit of tucker, and even its power to find a mate and have little ones. It's not just about comfort, it's about life and death. Understanding this is the key to understanding the secret lives of these magnificent animals. So the big question is, are you ready to dive into this amazing world with me? We're going on an adventure to find out what makes an animal warm-blooded or cold-blooded. We'll look at the champions that make their own heat and the clever critters that borrow it from the sun. It's a story of energy, survival, and some of the most fascinating adaptations you've ever seen. By the end of this, you'll be an expert, and you'll look at every animal, from your pet dog to a snake in the grass, in a whole new light. Crikey, let's get into it. Right then, let's talk about the first group, the endotherms. Now, this is just the scientific way of saying warm-blooded. These guys are the absolute legends who make their own heat. They're like walking, breathing furnaces. Think about us humans, your pet dog, a beautiful kookaburra sitting in a gum tree. We're all endotherms. We don't have to lie in the sun to warm up for the day. Our bodies are constantly working, burning up the food we eat, our fuel, to create a nice, steady, toasty temperature inside. It's a non-stop 24/7 operation, and it's what allows these animals to be so incredibly active. So how do they do it? It's all about metabolism, another big word for a simple idea. Their bodies are working at a really high rate, breaking down the nutrients from their food and turning it into energy. A lot of that energy is released as heat, which warms up their blood and keeps their whole system running smoothly, no matter what the weather's doing outside. This is why a mammal or a bird needs to eat so much more food than a reptile of the same size. They're not just eating to grow, they're eating to keep that internal fire burning bright. This ability to self-regulate their temperature gives endotherms a massive advantage. They can live almost anywhere on Earth, from the freezing icy landscapes of the Arctic, polar bears, penguins, to the hottest, driest deserts, camels. Because their internal temperature stays the same, they can stay active when it's cold. A fox can go hunting for its dinner in the middle of a snowy night, while other critters are fast asleep. The main groups of endotherms are mammals and birds. That's us, that's whales, that's kangaroos, and that's every feathered friend you can think of. They've developed some bonza features to help them hold on to that precious heat they make. Thick fur on a grizzly bear, dense blubber on a seal, fluffy down feathers on a baby duckling. These are all types of insulation, designed to stop that hard-earned warmth from escaping. They're true masters of their own climate, these warm-blooded wonders. What an incredible design. Now let's swing over to the other side of the animal kingdom and meet the ectotherms. These are the critters that folks often call cold-blooded. But that name is a bit misleading. Their blood isn't always cold. In fact, on a hot day, a lizard's blood can be even warmer than ours. The real difference is where they get their heat from. Ectotherms use the world around them, like little solar panels. They rely on external sources like the sun, warm water, hot rocks to reach operating temperature. They are incredibly efficient. Think about a snake or a lizard in the morning. What's the first thing it does? It finds a sunny spot and lies there, soaking up rays. It's not being lazy, it's charging its batteries. The sun warms its blood and gets its muscles ready. Without that warmth, it'd be slow, a sitting duck for predators. This group includes crocodiles, snakes, turtles, lizards, frogs, fish, insects. One big advantage is energy conservation. They don't burn food to stay warm, so they eat way less. A big crocodile can eat once and go months without food, even up to a year. Can you imagine that? A lion or a wolf would starve to death in that time. Low energy needs let ectotherms survive where food is scarce. They find a safe spot, slow their system down, and wait for better conditions. Downside, weather rules their lives. When it's cold, they get cold. Activity levels plummet. That's why you don't see lizards in the snow. In cold places, they brumate, a reptilian hibernation. They hide in burrows or deep underground and wait out the cold. It's a dance with the sun and seasons, warming up and cooling down. So let's put these two incredible groups side by side. It's like comparing two different types of cars. The endotherms, our warm-blooded mates, are like high-performance racing cars. They have a powerful engine, their high metabolism, that's always running, always ready to go full throttle. This means they can hit top speed anytime, day or night, hot or cold. But just like a race car, they burn through a massive amount of fuel. They need to eat constantly to keep that engine running. A tiny little shrew has to eat its own body weight in food every single day just to stay alive. On the other hand, our ectotherms, the cold-blooded crew, are more like super-efficient electric cars. They don't have a big fuel-guzzling engine running all the time. Instead, they park themselves at a charging station, a nice sunny rock to power up. Once they're charged, they can be just as fast and active as anyone else. But when the sun goes down, or the weather turns cold, their battery drains, and they have to slow down. The trade-off is amazing fuel economy. They can go for an incredibly long time on a single charge of food, making them perfectly suited for a different kind of life. Think about their daily lives. A warm-blooded mammal, like a badger, wakes up and is instantly ready for action. It can start digging and foraging for breakfast straight away, even if there's frost on the ground. A cold-blooded reptile like a goanna has a much slower start to its day. It has to spend the first part of its morning just getting warm enough to move properly. This difference dictates their whole lifestyle. Endotherms can have complex active social lives. Endotherms can migrate huge distances, while ectotherms often have lives more tied to a specific location with the right temperature conditions. And what about their body's endurance? An endotherm has amazing stamina. A cheetah can't sprint forever, but a pack of wolves can chase their prey for hours, wearing it down, because their bodies keep producing the energy and heat they need. An ectotherm often relies on short, sharp bursts of speed. A crocodile can launch itself out of the water with explosive power, but it can't sustain that effort for a long time. Once that initial burst of energy is used up, it needs time to recover. It's two completely different but equally successful blueprints for survival. So at the end of the day, why does any of this matter? It matters because this single difference, how an animal gets its heat, shapes the entire web of life. It determines who lives where, who eats what, and who is active when. The world would be a completely different place if all animals were warm-blooded or all were cold-blooded. The beautiful balance of nature depends on having both of these amazing strategies at play. It creates diversity, it creates opportunity, and it makes the animal kingdom the magnificent, complex place that it is. Every niche gets filled. Think about the food chain. The high energy needs of endotherms mean they are always on the hunt, which shapes the populations of the animals they prey on. But their need for so much food also makes them vulnerable. In tough times when food is scarce, it's the endotherms that suffer first. The ectotherms, with their slow and steady approach, can often wait out the hard times. This difference in energy use means that an ecosystem can support a much larger biomass. That's the total weight of all the animals, of ectotherms than endotherms. Insects, fish, reptiles. There are simply more kilograms of insects, fish, and reptiles out there than mammals and birds. This fundamental difference also explains the very shape and structure of animal families. Endotherms, like birds and mammals, often invest a huge amount of energy into raising just a few young. They protect them, feed them, and keep them warm, teaching them the skills they need to survive. Many ectotherms play a different game. A sea turtle might lay 100 eggs and leave them to fate. It's a numbers game versus a quality care game, both driven by the core principle of energy management. Ultimately, whether an animal is a warm-blooded, furnace-like endotherm or a sun-soaking, efficient ectotherm, it is a survivor. Each strategy is a masterpiece of evolution, perfectly tuned over millions of years for a particular way of life. There is no better way, there are just different ways. So next time you see a bird flying high in the winter sky, or a lizard basking on a fence post, give them a little nod of respect. You're looking at two champions of survival who have mastered the art of living on this wild, beautiful planet. What a wonder.